All right. So for the review, number one, Starburst. At one time, the intended distribution of flavors in a package of Starburst was equal parts: strawberry, lemon, lime, and cherry. Suppose we opened a random sample of Starburst and observe the counts below. Does the data indicate that the stated distribution has changed? So first thing we need is the total. And for this one, it's 100. There's 100 pieces in there. If it says, since it says equal, that means you divide by, the expected would be 25 each. Now, on these type of problems, hint, hint, if you see a problem and it doesn't actually say equal and it doesn't give you a breakdown of 5% here, 20% here, just assume this should be broken down equally. All right. If you don't know and it doesn't give you percentages, assume equal distribution. All right. So we break it down. And now you'll notice here, it does not have the box here with the steps, but you have examples in your notes of the steps. So we're first going to do the ho and the ha. And the ho and the ha for these are very easy. For the ho, we just say the distribution has not changed. And for the ha, we say the distribution has changed. Okay, so pretty simple there. Then we're going to check our conditions. So random. That was given to us. It said it was random, so check. Expected counts. We look at all of them, 25, 25, 25, 25, greater than or equal to 5, check. Remember, we're not going based on the number of things in the survey. This is expected counts when we're doing with chi-squared. Now, we're going to find our x squared. Now, remember, the formula is you take the actual amount minus the expected amount, you square that, divide by the expected amount, and then you add all the different ones. There's only 4 here. It would not take long, but we're going to let technology make our life easier. So we are going to go to this chi-squared calculator, this first one, which is right here. We're going to put our observed in of 28 and 27 and 22 and 23. Our expected for all of these is 25. And then we just go calculate down. And right here, it gives us all of our information that we need, which I'm going to write then on here. So x squared is 1.04. And it gave us our p-value of 0.7916. And last thing we do is, we make our graph. 0, 1, 2, 3, 7.9, 1.04. Here's 1 right here. So 1.04 is going to be really close to that line, and we just shade. So the area under the curve is 0.7916. So 79% right there. And let me say, since my p-value, which happens to be 0.7916, is greater than my alpha, not infinity, just alpha, which is 0.05, we fail to reject the ho, or the null hypothesis. We conclude there is no change in distribution. Okay, this one is about tattoos. It says study from the University of Texas examined whether the risk of Hep C was related to whether people had tattoos and to where they got their tattoos. The data is summarized in the table. Do these data provide convincing evidence that there is an association between Hep C and where you got your tattoo? So we have positive Hep C, negative Hep C, a tattoo at a parlor, tattoo somewhere else, or no tattoos. All right. And then here's your breakdown of the numbers. You can see the majority of non-Hep C was from not having tattoos. And there's our total 632. Remember, we're not putting these numbers into our calculator. Okay. We only put these numbers here, the actual data we gather. All right. So again, our ho and our ha is really easy. So first one is no. There is no association between Hep C and tattoo location. And then for the ha, we say there is association between Hep C and tattoo location. All right, now remember for this one, we're going to go to Staplet and pick one categorical variable, multiple groups. And we're going to put in 17, 35, 14, 53, 53. We need to add a category, and 22 and 491. Now remember, when you're doing these, we don't need to put in, the study and the different groups and everything. We don't have to put all these categories in because we're just crunching the numbers. Make sure this is on a two-way table. If, I think that's the default when you come here, but if not, make sure you're on a two-way table, right? Then you do begin analysis. Again, these are good things to have for, project graphs you can put in copy and paste into a project, right? But the important thing is then to come down here and pick chi-squared. As soon as you do that, you'll get your chi-squared, you get your p-value, and you'll get your expected counts. It even gives you a warning. At least one expected count is less than 5. And that's this one right here. It's close. It's 4.4, almost 4.5, but it is less than 5. So when we come back to our thing here, we're going to make it a little expected table. And it doesn't have to be really fancy. You can put boxes. You don't have to really, but if you want to, you can. I'd be fine if you just write it down. It says 4.361, 5.619, 47.639, and 61.381. So you just make a little expected table since we didn't add that to our regular table. It's a little bit different than the previous chi-squared problem. And then we're going to check random. That was given. So, okay. And then expected counts. And we're going to actually put a warning here. One group is less than 5. So proceed with caution. All right. If they were all above 5, then you would just check off, yes, we're good to go. And then our information we got from the calculator was our x squared was a huge number, 64.845. And this happens sometimes. So obviously when you graph this, 1, 2, 3, this is just going to be this tiny little amount out here. I mean, 64 is like off the chart. And the p-value was teeny tiny. It was 0.001. That's the area under the curve right here. So like a tenth of if we move the decimal over, a tenth of a percent. So that's teeny tiny. All right. Think about a penny from a dollar is 0.01. So this is tiny, tiny, almost nothing. And then we go with our statement. Since my p-value, which was 0.001, is less than alpha, nope, going the wrong way, which is 0.05, this time we are rejecting the HO, the null hypothesis. So we conclude that there is an association between Hep-C and tattoo location.